So if we're looking at this graph, then let me make that a little bigger. What's the value of A? 1/2. Now, what does that mean? The slope of where? Now, if it's an absolute value function, what's the graph always going to look like? A V. Good. It's always going to look like a V if it's an absolute value function, right? This is the slope of the right-hand leg or side of the V, right? So A is 1/2, which is slope of the right side. Now, what are the coordinates of the vertex? Those are H and K, right? Not -2, right? -2, because we're comparing this to the standard form, which is A times the absolute value of X minus H, right, plus K. So we just want to know what values would we plug in for A and H and K to get this. That's not hard to do. It's much, much easier than having to take the time to put this on a graphing calculator, tweak the window to get the window right. That stuff takes time. This doesn't. So H is -2. What's K?
0.
So then this is pretty simple. We're looking for the V-shaped graph with a vertex at -2, 0, right? So on the y-axis down 2, where the slope of the right-hand side is rise 1, run 2. That's pretty simple to find, isn't it? I mean, that's a lot easier than the alternative. So let's just, let's find that. So let's see if we go down. Those aren't V's, those aren't V's, those aren't V's yet, but those look like V's. Okay? So we want to be at -2, 0. Oh no, those weren't V's. Those are V's. Okay, -2, 0. Stop me when you see one with the vertex at -2, 0. Right there. Is that the right? No, it's not quite. That's actually, if you look closely, that's -2.5 in the slope plane. Oh, this one right here. Good. Okay, -2, 0, and that's what we wanted, isn't it? There you go. Let's check the slope. Does the slope work? So if we go, there's a point, and then there's a convenient point. Sure enough, I'm rising by 1 and running by 2. That's it. Easy, right? Isn't that way easier than having to worry about graphing the whole thing? Way easier. Okay. So, same thing could be true for a piecewise function. With the piecewise functions, don't bother trying to put it in your calculator. That is way more trouble than it's worth. Just find with the, let's look at one of those, and then we'll go to the lab. These seem to be the ones that people are having the most trouble with, and honestly, they should be some of the easiest ones because you're just identifying a graph. Let me grab one of these. Piecewise. Okay, here's an example. Can everybody see that equation okay? Okay, so then if this is the equation, now how are we going to pick this one out? We need the piecewise functions. How many pieces does this one have? 2. So we want one, so it can't be that one. That's got 3, right? We want one with 2 different pieces. And where do the pieces break? Meaning, where's the vertical line that separates one piece from the other? At 3. Okay, good. So there's where they're gonna separate. Now, which one goes on the left? So if I end up doing, I can kind of anticipate what this is gonna look like. Out here at 3, I'm gonna have my vertical line. To the left of that line, which one gets graphed?
X minus 10.
Yeah, so over here I'm graphing y equals x minus 10. On the other side I'm graphing. Okay, that's no big deal, is it? All I need to do if I want to even sketch a graph of this is just find 2 points that I can connect on this side, connect and extend, and 2 points on this side, right? The points don't even have to be on this side. They could be over here, and I could just use them to line up the ruler. But you guys are getting good enough at this now that why don't we just pick the points, convenient ones, that are You'll have pick points on the left side for this graph and on the right side for this graph. Just make a simple little t-table. Like over here, this one includes the y-axis, doesn't it? So my points could be at -10, at x equals 0, -10. There's the y-intercept if I want to. So I'll go way down here to -10. And then my slope is 1 over 1, so I'll rise 1 and run 1, and that's pretty easy to see, right? That's easy to identify. There's the y-intercept, and the slope is 1. What about this side? Over here, well, if I make a t-table, I could pick a value like, I don't know, even 3, how about? If x is 3, and I plug 3 in for x, what do I get for y? -3 times 3 is, -9 plus 1 is -8, whoops. So 3, -8, and the slope is -3. That's not bad to find, right? There's a point that it goes through. Let's just go find that one. So we want to break at 3. Tell me when you see one with a break at 3. That one has a break at 3, doesn't it? Well, let's check it. Is that it? That looks pretty good because look, on the left side, the y-intercept is -10. The slope is 1. Check. What about the other side? Does it go through the point 3, -8? Yes, it does. And the slope is -3. 1, 2, 3 over 1. That's it. See how easy that is? So it's not worth trying to put this on a graphing calculator. That's way more trouble than it's worth. Just find the identifying characteristics, and like the thumbprint, and go find the one that fits. Okay? Make sense? All right, let's go. 332.